first begin with looking at the homework. And the first few are just to refresh on what inverse proportions are, and then we'll get to the big problems as well. Some of you guys were struggling with it, so it's okay. I'll go over them. So first, the first one is just to refresh up on the inverse proportion. So for inverse proportion, right, the two variables, they multiply to a constant product. So when you multiply them, they're always the same. So that means when one goes up, oh, that's not what I want. This. So when one variable goes up, the other variable will go down. So when n equals 24, w equals 3, right? So if we find a constant product, that is 24 times 3, and that's equal to 72. So that means no matter how n and w changes, they will always multiply to 27. So now we just have to substitute this in. So n times w is equal to 72. So when w is 12, essentially that means 12 times n is equal to 72. And that just means that n is equal to 6. And I know that Emma went to look at the Khan Academy video. I don't know if anyone else did, but they have another way of doing it, and it works as well. So depends on which way you want. I didn't talk about this last time, but essentially you draw out a table, I think, right? So let's say this side is n and this side is w. So since this is an inverse oh, so n is wait, was it 24? Yes, 24 and 3. So since this is inverse proportion, whatever you times this by something, you just divide this by something else. Oh, actually, it's the other way around here. Yeah, other way around. So in this question, it would be the other way around. So when you times w by something, you divide n by the same thing. And that is what it means by a constant product in inverse proportion. So w went from 3 to 12. So 3 times 4 is 12. So that means you have to divide 24 by 4. So then w becomes 12, and n just becomes 24 divided by 4 is equal to 6. So that is another way you can do this. And you see we get the same answer. And this just verifies what I said about inverse proportions, right? When you change the factor, when you multiply something by a factor, right? Like this is by a factor of 4. So by a factor of 4. What I said last time was that you change this, times it by 1 over that factor. And divided by 4 is the same thing as times 1 over the factor, because when you divide something, that's divided by 4 over 1, and that's essentially equals to timing it by 1 over 4, right? So divide by 4 is the same thing as timing it by 1 over 4. And when you times this by 4, is the other side, the other variable, you have to times it by 1 over 4. So always remember for inverse proportion, when one variable goes up, the other variable goes down. But then, yeah, so some of you made the mistake of when you times it by one factor on one side, you did it to the other side again. So when you times it by 4, you times the other variable by 4 again. That is called a direct proportion. That's not inverse proportion. So number 5, this one essentially the same thing. So for the first method, so first you find the constant product. So that is a b times a, right? So a times b is equal to 5 over 3 times 7 over 4. And that's gonna give 35 over 12. Yeah. And then we just use this condition. So AB is equal to 35 over 12. So then 12A is equal to 35 over 12. So I just substitute in B equals 12. And then A is, so divide 12 on both sides. We get A is equal to 35 over 144. Now you could try the other method as well, this method. It works, but what you are going to realize with fractions is that it gets really complicated. So A was originally 7/4, right? 7 over 4. And then B was originally 5 over 3. And then now we changed B to 12. And we want to find out what this is. Well, first you have to figure out what is it multiplied by. And I think it's pretty obvious to see that this is hard to do. So like for this question, you can just directly tell that 3 multiplied by 4 is equal to 12. So then you can just do divide by 4 on the other side. But for this one, it's really hard to say you can't look at it by eyes. What you can do instead, you can solve an equation, but that's just like one extra step. So 5 times x, so I'll do it here. So x, right? So multiply by something. Actually, I would not use x. I'll use m. So that's our variable. Multiply by m. 5 over 3 multiplied by m is 12. So when you solve this equation, you have to, so 5 over 3 times m is equal to 12. So then you divide 5 over 3 on both sides. So you have to divide by a fraction, and that doesn't look nice. So m will equal to 5 divided 12 divided by that is 12 multiplied by 3 over 5. So m is equal to 36 over 5. Yes. So now you know that this is 36 over 5. See, you can still do it. No problem, but it's just so much work now. Then that means on this side you have to divide it by 36 over 5. So then 7 over 4 divided by 36 over 5. Oh, that's the same thing as 7 over 4 multiplied by 5 over 36. And that's gonna give the same thing. 35 over 144. But you see how first we have to figure out this. So what is it multiplied by? And then you have to divide that number again. Whereas if you just use the constant product method, you find the constant product, and then you can just directly solve. You still have to solve an equation, but you only have to solve one. Whereas if you use this method, first you have to solve, and then you have to do this extra step with fractions again. So yeah. And then number 8, oh, this is a different one, tricky. So it was a trick question, I'm gonna admit it. So again, the constant product. is equal to m times n, and that's equal to 3 times 3, so 9. So then we plug in this condition. So mn is equal to 9, and then, so what is mn? N is 0. So I'm saying that 0 times m is equal to 9. Now the thing here is, m actually, there's no number that satisfies this equation. Because imagine, right? Plug in any number for m, you get 0. 0 times any number is equal to 0. So that means m cannot exist. So in this question, m is actually not all the numbers. It's actually no number. None of the numbers work. And if you can see, you you can try dividing on both sides by 0. And I hope you already know this, but you cannot divide anything by 0. So that's just totally wrong. So what we say when there are no numbers, we say that it is undefined. So don't get confused when you solve an equation like this. When you solve like x equals x, then x is equal to all the numbers, right? In this equation. But in this equation, 0 times m is equal to 9. There are no solution. So you cannot find any value of m. Whereas in this equation, you can find any number works. So they are completely different. Or I can say just the opposite. So any questions so far about these 3 questions? Concerns, issues? If you don't have any, just type into the chat. Oh, you can't math? No, you can, Emma. So is there a question or no? I'm guessing no. Nope. Okay. Other people? Good. So, okay. Oh, no, okay. So I will go on to the word problems. Wait, what? What? Why is it here? Oh no. Oh, this was the whiteboard from last time. Forgot to use a new whiteboard. Sorry. I'll copy and paste everything onto a new whiteboard. Cut. Okay, that's sad. Yeah, create new whiteboard. There we go. Okay, that's better, right? Yeah. So number 10. So Honda Civics drove 86 kilometers, and then the car maintained an average speed of 43 kilometers per hour and made its destination in 2 hours. And that makes sense, right? 43 times 2 hours, that's 86 kilometers. Now, if the speed were to increase by a factor of 3, so that means multiply by 3 if you didn't pick that up. So, oh, decrease. Sorry. So you divide by 3. My bad. So divide by 3, not increase. Divide by 3. How long will it take instead to reach the destination? So, so the formula for distance, I think all of you know, is equal to speed times time, right? So the speed times the time is equal to distance. So you see this multiplication over here? And then you see that the distance is 86 kilometers. That one didn't change in the question. That means, what is this? Inverse proportion. So of course it's dealing with inverse proportion because that's what we learned last time. So this is a constant. And then these two are inversely proportional, IP. Okay, so actually we already know uh, what the constant product is. So we can actually just do this part over here. So you know the distance is 86, and that's equal to, so what's the speed? Well, originally the speed was 43. So now it's decreased by a factor of 3. That means the speed now becomes 43 divided by 3, right? And then multiply this by the time, because that's essentially what we want to figure out, time. So now I can just solve this equation, divide both sides by 43 to isolate the time. And you will get that t is equal to 6. So t is equal to 6 hours. And then we want an answer statement. Always remember, for a problem, you want an answer statement. What was it asking? Oh, it will take 6 hours. Now for this question, this is where that Khan Academy method actually is easier. Because when you solve this equation, you have to solve something with a fraction. And we always like working with integer more than with fractions, right? Like so long that we can avoid fractions, we avoid fractions. So let me show you why the Khan Academy video method is actually better in this case. So this is speed, right? And this is time. Because initially we are already given what the speed and time was. The speed, oh, 2, yeah, 2. So we know that the speed divided by 3. So on this side, we just have to multiply by 3. So do what's the opposite of the other side. So we don't even need to figure out this. Don't need. Because the question is asking for this. And 2 times 3 is just 6. It's just as simple as that. So you see, it's only a one-step thing. Well, here you still have to solve an equation, and that's a bit more complicating. So different questions with different questions, you should try to use different methods. So whichever method is faster for that question, use that method. And as for how you would see which method would be more beneficial, that takes practice. No shortcut. So yeah, so like do more practice and then you will find out like what is the best way to approach a problem. Because I can tell you that both methods are useful at different times. And as you can see, so very obvious, this one is much better with finding the constant product and then solving equation. Whereas this one is much faster with setting up this table thing over here. So that is number 10. The answer is 6 hours in case you got the wrong answer and you wonder why. So number 11. Now this one is a bit tricky, I think. So force is equal to mass times acceleration. This is a physics formula. Yeah, so it's about physics. So a constant force of 200 Newton is applied to a 25 kilogram wagon. If 1/8 of the mass was removed, what will happen to the acceleration? So again, in this question, the force unchanged. So, oh, a constant product here. Mass times acceleration, unchanged. Good. So we usually write F equals ma. That's the short mass ma. So, so we know the constant product now is equal to 200. Constant force, constant product, same thing. So we need to find the, in order to find the acceleration, so we have ma equals, right here. So ma equals 200, right? So we want to find the acceleration, we need to know the mass. Okay, so what's the mass? Originally it was 25, but now 1/8 of the mass was removed. So what is, how much mass is removed? Notice it didn't change by a factor of 1/8. That's the difference. It didn't change by a factor of 1/8. 1/8 was removed. So first we have to find out how much was removed. It's 25 times 1/8, and that's, I don't know the numerical value, but I'm just gonna say it's 25 over 8. So how much is remaining? Well, remaining, it was 25 originally, and then we have to minus that by 25 over 8. So that's the removed. And that is gonna give me a calculator. Oh yeah, and I forgot to mention, when you do these questions, you don't need to do everything by hand. You can use a calculator. So I often use a calculator myself. 25, 175 over 8. How I got this was I didn't actually minus this. What I did was the same thing. So if 1/8 was removed, that means 7/8 is remaining, right? So 7/8 remaining. So what I punched into my calculator was actually just 25 times 7 over 8. And that is giving me 175 over 8. So that is the remaining mass. So now we substitute this into here. So MA is 200, and then M is 175 divided by 8. And then we want to find out what A is. A is unknown, acceleration. So that's equal to 200. So divide 175 over 8 on both sides. And we get that acceleration is equal to, again, I'm going to use my calculator. 8 divided by around 9.14. So the unit for acceleration is meter per second squared. You don't have to worry about that. Don't worry about that. But just to let you know. So that's how you do it. Oh, you can leave it as a fraction as well. So uh, let me just do the calculation here. So 200. So this is the same thing as times 8 divided by 175. And then you can cancel out the y25 here. So 175 divided by 25 is 7. 200 divided by 25 is 8. So yeah, the answer is 64 over 7. Oh, and remember when you cancel things out that the numbers still exist. So don't just write like 64. The one on the bottom also exists. Don't neglect that. So 64 over 7. That's the same thing as around this. Okay, so these are the two word problems. Any questions on them? Oh, good. Okay, I'll take that as a good. So the conceptuals, yes. Now the last three, as I told you, that they were not very well asked. My bad. That's my bad. The questions were not very good. So I'm just going to talk about the first two then. So yeah. Actually, now that you heard me reviewing all this, how about the constant product and then also this new method, and how when one goes up and the other goes down, I want you guys to answer these again. Yeah, so I want you guys to answer these again. And maybe I'll just change this multiply. Now, however, when you answer, you cannot use the word divide. You still have to use the word multiply. So what is it multiplied by? What happens to x? So x is multiplied by something. By maybe if you can't think of what is multiplied by, just say what is it divided by. But again, I want you to tell me what is it multiplied by. So type it into the chat. Oh, and Tim, if you call on to anything, maybe you can try out as well about inverse proportions. Okay, x is multiplied by 1/3. And how about the second one? And everyone else, if you disagree or agree, say that, type into the chat as well. So I want you to answer both questions at the same time. It's okay, because we'll talk about them at the same time. You don't know too. Okay, that's okay. How about someone else? Nobel? Chloe? Emma? Oh, Chloe, you're private messaging me. You want to type it into the chat? Yeah, it's okay. Yeah, the 10x server and then the class C chat. Yeah, yeah, I will say, yeah, the first one is right. So the first one is multiply by 1/3 or divide by 3. And I want you to recognize that they are the same thing. Because whenever you divide something, that's the same thing as multiplying by 1 over that number. Because 3 is essentially 3 over 1, right? 3 divided by 1. So when you divide a number, I think you guys learned this, that you it's just multiplying by the recipient. So multiplying by, like, when it flips over. So divide by 3 over 1 is the same thing as times 1 over 3. And so they're just flipped over. B. Oh, divide by 4 over 7. Okay, so what is it multiplied by then? I want you to give me an answer in multiplication. So remember how I talked about when you divide a number, so 3 over 1, that's the same thing as timing it by switching the numbers around, top and bottom. So 3 over 1, 1 over 3. James, what do you think? What is it multiplied by? Okay. So, okay, maybe I'm confusing you. Maybe that's why. So yes, you are right. So, first, multiply by 1/3. That is the correct answer. You got that one. And then this one divided by 4 over 7. That is also correct. Your answer is correct. I'm not saying it's wrong. But I want you to express it as a multiplication. So, well, so why is it divided by 7? Well, first, maybe I'll talk about why is it this first. So this is this first division, okay? So divided by 3. So for number 1, x and y. So the number over here, well, we don't really know, but it's okay. Because, so imagine these are two numbers, okay? So these are two numbers. So y is multiplied by 3. And then, as we were saying, you just do it to the other side, divided by 3. And because I'm not looking for what the answer is, I'm actually just looking for this part. So divide by 3. So when a number divides by 3, that's the same thing as multiplying by 1 over 3. And 3 is the same thing as 3 over 1, right? Now, so as James was saying, this is the same thing as timing it by 1 over 3. And that is actually what I want you to say. And for number 2, it's actually exactly, well, not exactly the same. It's a bit more complicated, gotta say. But not really. No, it's B and R, right? So first, I have a B, some number, and then another number is R. So R is multiplied by 4 over 7. And since we don't care what the final value is going to be, we just care about this part, divided by 4 over 7. So times 4 over 7 divided by 4 over 7. And then, oh, so divide by 4 over 7 is correct. But then, I want you to express it as a multiplication. Now, why do I want you to express it as a multiplication? Because when we say that we change something by a factor of something, that is always saying multiplication. So even if it's like changed by a factor of 4 or 7, that means R is getting smaller. But even when R is getting smaller, it's still a multiplication. Just the fraction is less than 1, so R is getting smaller. But when we say change a factor by something, it's always a multiplication. So divide by 4 over 7. So like if you can imagine, right? Like what would you do when you do like 5 divided by 7? How would you calculate that? Well, you would calculate 5 times 7 over 4, right? And when you do 5 times 7 over 4, that's equal to 35 over 4. So when you divide something by 4 over 7, it's times 7 over 4. And that's simply what I want you to get at. You multiply it by 7 over 4. Does that make sense? Like this is that it's just as simple as that. I want you to get to this part. Like these two expressions, they are exactly the same. Just because I changed it to a multiplication doesn't mean I changed anything. Divided by 4 over 7 is exactly the same as 7 over times 7 over 4. Okay? Does that make sense, guys? Now, but I don't want you to get confused though. When you multiply R by 4 over 7, you cannot do this, okay? So like no, that is wrong. That is not right. Because you multiply it by 4 over 7 on this side. You have to divide it by 4 over 7. You don't multiply by 4 over 7. You divide it by 4 over, you divide by 4 over 7. And times 4 over 7 is different from times 7 over 4. The very different, if you can, well, not very different, but they're exactly the opposite. So does it make sense? If it's not, just say no. I will try to explain it in a different way then. So what I want you to get at is multiply by 7/4. Okay, maybe I will ask you guys this. So type this into the chat, okay? So divide something by 9/5. What is this equal to? Times it by what? Type this into the chat, the answer. Yes, 5/9. Yep. And that is just how you do division or fraction, right? You times it by the, so this is, yeah, I didn't want to use this term because it might get confusing, but like you times it by the reciprocal. That is what it is called. When you flip something around, it like flip something in a fraction, that is called time the reciprocal, okay? So I'm just gonna use that word. So 3 is the same thing as 3/1. And the reciprocal is when you flip this around, so it's 1/3. So you guys know that the y by 9/5 is equal to timing it by 5/9. Well, how about this? Times 3/4. What is it divided by? What's this number here? Yes, that is good. Good job. See? Just flip it around from one way to the other and from the other to back to multiplication. Same thing. You just flip the numbers around. So do you see now why, like how, do you see why this is true? Like the y by 4/7 is the correct answer. It is correct. You're right. Because of this, because of inverse proportion. But when I want you to express it as a multiplication, you just, all you have to give me is say times 7/4, so the reciprocal. Okay? Good? Yes. Okay. So that was the homework. Oh, maybe I'll write this down somewhere. Um, you guys can refer to it. So, oh, reciprocal, yeah. That is how you spell it. So flip the numerator and denominator. And that's all I want you guys to do. Okay? So today I think we should just be do some review on direct proportion and indirect proportion. So last two times, first day we talk about direct proportions and then indirect proportions, and then today will be just briefly or not so in-depthly, yeah, not briefly, in-depthly reviewing what they are. So first we're going to start with direct proportion again. So I will just give you the key properties, right? So just always remember these key qualities. So quantity A. So a proportion, direct and indirect alike, uh, are ways to express a relationship between two quantities. So I will say that quantity A over quantity B. So this is a constant. When you divide them, it's a constant quotient. So this idea of constant might be new to you guys, right? So essentially it just means it is a number. So you can, like, for the sake of understanding, you might just assume that this number can be 3. Now this number will change depending on the question. But then within that question, this constant will never change. So so when you do a math problem, you can always assume that a constant will never change throughout that question. So a constant. So sometimes they will give you a constant like k is equal to 5. Sometimes you might have to find that constant and you have to do things to find that constant. But you can always assume that a constant will never change in a question because that is what constant is. Oh, yes, I'll put this up here because that's not really related to direct proportion. It works everywhere. Put it up here. So you can always assume that constant will never change throughout that question. So for direct proportion, constant quantity A over quantity B, that gives a constant quotient. So as we, so how we represent this using something fancy can be A is proportional to B, this fancy symbol over here. And the other way we can represent this is actually saying that A is equal to K times B, and here it is again, the constant, where K is an now arbitrary, this word here. This means that I can let k be anything, but it is always constant. It remains the same within a question. So for any questions, the person who come up with the question can let k be anything. But then that k value is always going to stay the same throughout that question, okay? So now here's something fun. When you divide both sides by b, what do you see? You get a over b is equal to k, right? And look here, a over b is a constant quotient. So this k constant is essentially the quotient. So when you write it in this form, oh, I won't delete it. So in the form a is equal to kb, k times b, k is essentially the quotient of a and b. So a divided by b is equal to k. Okay. So like even though like you just saw a new way to represent direct proportion, but what it means is the same thing. A divided by b is always remains constant, a constant quotient. Okay. So now how do you recognize a proportion? So direct proportion. Now so this is helpful when you're doing questions, I guess. Like if you want to know how to start solving a question, because right now I'm telling you guys that all these questions are the proportions, but when you do an actual contest, say, they won't tell you uh this is a proportion question, so you have to recognize it yourself. Or in real life, it also helps because when you see something, you will see that recognize that, oh, this is constant proportion or indirect proportion. So number one, cost and amount of product. So usually when you see something like this, like the cost of apples, the cost of oranges, that's the amount of product. Yeah, it's a good hint that this is a direct proportion question. When cost goes up, I'll just say this, amount, product, just, oh, yeah, I don't mean like multiplication here, I mean like actual stuff, okay? Like stuff you buy. Stuff goes up as well. And then the other very notable situation is speed and distance. Well, yeah, speed and distance. Speed and distance given the same time interval. So what I mean by that is that, so within an hour, like let's say an hour is like your time interval, right? Then when speed goes up, the distance you travel is naturally going to go up as well. So of course you cannot compare like 1 hour and like distance you travel in 1 hour and 2 hour. These are completely different. They have to be the same time interval. Okay, and then actually, can you guys think of an example? Then type it into the chat. Yeah, think of an example of direct proportion in real life and type it into the chat. Give you guys maybe like 3 minutes to think of one. Anything? Emma? Chloe? Oh, yes. That is nice. Yes, that is true. The more water you use, the higher the water bill goes up. Same thing with electricity. Good. Nobel, you have an idea? Uh, yeah, yeah, that is good as well. So the uh the distance and gas consumption. Yes, good, good point. Yeah, so I'll write these down actually. So amount of water usage and uh water bill. I guess that's kind of cost as well, because you can say that water is a product. Water up, money up, and then gas consumption, right? So yeah, good. distance goes up. And all by consumption, make sure you remember that this is not what is left, okay? So this is what is used. Okay, so I guess we can leave it from on here. And then, so the general rule of thumb. And I talked about this the first time, but I want you guys to remember again. Remind you, always keep this in mind. For direct proportion, when one quantity goes up, other quantity goes up as well. When one quantity goes down, other quantity goes down as well. Okay? So, draw a squiggly box around this so that you remember to look at it later when I post the notes. And then, oh, I'll draw a squiggly box around this as well. These two are essentially the key notes that you would want to review. So now we'll get back onto inverse proportion. So the good thing that we have been talking about for the last 2 days, inverse proportions. It's hard, I know. But if nothing is hard, how will you ever improve? Just always gotta push yourself. So inverse proportion. So for inverse proportion, A times B is constant. And we say, last time I said that how you represent this is A is proportional to 1 over B, right? Now, so remember how here we have this form over here. A equals K times B. Well, we can also do the same thing here, except we say that A is equal to K divided by B. Now, why does this work? Because, again, you can try to multiply both sides by B. And you will get that A times B is equal to K. So this means that essentially, oh, not eventually. Essentially, K is the constant product. Right? And maybe this is kind of Like if you look at the form over here, right? Don't you think it's kind of similar? So this here is a 1, by the way. So 1 divided by b. So a is, so when we say inverse proportion, we say a is proportional to 1 over b. So a is inversely proportional to b. And then here we have a is equal to k divided by b. So kind of notice this. Oh, and like over here, right? A is proportional to b, and then a is equal to k times b. Because essentially, when k is equal to 1, then a is equal to b, right? So then a is equal to b. So that's like how you can kind of treat it. But of course, k can be any number, but within the question is the same. So a times b is equal to k. And I guess I'll write the other quantity over here. So when one and goes up, the other quantity goes down. Now I want you to recognize from this form as well, okay? So let's say that k is equal to 2. I'll say that k is equal to 2. So a is equal to 2 divided by b, okay? Now, so let's say b goes up, okay? So when b is 3, right? So then let's make a table. A and b. So when b is 3, a is equal to 2 divided by 3. When b is 5, a is 2 divided by 5. Now let's imagine a really big number. B is, so then A will be equal to 9 divided by this number. And you see how when B goes really big, A actually gets smaller and smaller. Like 2/3 is approximately like 0.67, right? What's 2 divided by 9? This 9. Well, let's see. 2 divided by 1, 2, 3, 4, 5, 6. 6 nines. So that is approximately 0.000002. 0.1234 zeros. And this here is approximately 0.67. So when b is small, see when one quantity, so originally it was small and then it's 0.67. When one quantity goes up, see it goes up. So goes up. Here's 0.67 to this really small number. This goes down. Now how about this? Now I'll change b. I'll make b go down. What happens? So let's say b is equal to 2 over 9. Here, can you figure out what a is for me, please? So a is equal to 2 over b. So when b is equal to 2 over 9, what is a equal to? Type it into the chat. Now, if this form looks confusing, maybe you can change it into this form as well. So a times b is a constant. So what would be the constant in this case? And when you find the constant, it's actually, I'm just asking the same question as what I have been asking last week, the homework questions. But what is a when b is equal to 2 over 9? Given this here. So I want you to find A.
Nine.
Yeah, yeah, Tim got it. So yes, A is just 9. So Y. Essentially, I'm just substituting B into here. So A is equal to 2 over B, right? So A is equal to 2 over 2 over 9. Now, realize that a fraction is a division. So when you 2 divided by a fraction, that's the same thing as equal to 2 times 9 over 2. 2 divided by 2 over 9, that's the same thing as 2 times 9 over 2. And that is equal to 9. Okay? Well, I'll clean this up later. Yeah, I'll still keep the notes later, but right now I'll get rid of it. Now for inverse proportion, I will only talk about this right now because for the last 15 minutes I want to talk about something else. So for the lesson, for the review portion of today, I think this